Hello everybody, welcome to our second lesson on Unit 1, Rational Numbers, Addition and Subtraction. Today we are talking about how we can use modeling to work with something called the additive inverse. This will make more sense in a moment. But we're still working with this standard, 7 NSA1, that is all about integer addition and subtraction and modeling it in a number of ways, including number lines, integer pieces, or drawing. Our essential question is, how do you model integer addition and subtraction? So going over a couple of pieces of vocabulary first, and some of this might sound familiar and some of this will be new. What should sound familiar is this idea of the additive identity. So the additive identity is the number 0, basically, because when you add 0 to any number, you get the same number that you started with. So for example, 3 plus 0 is 3. So in general, x plus 0 will be x. So the additive identity is 0. What's new and what our topic is for today is this additive inverse. And the formal definition of the additive inverse is that for every number a, there's a number negative a, so that a plus negative a equals 0, and negative a plus a equals 0. And this might help you if you're thinking about our peek at the number line or review what you know about the number line from yesterday. Just remember that, so it's kind of like that absolute value thing too, right? Every time you have the absolute value of a number, there's two of them on there. They have a pair, an opposite. So we also refer to our additive inverse as our 0 pairs or our opposites. Here's an example of it. So the opposite of 3 is negative 3 because 3 plus negative 3 equals 0. Hence, negative 3 is the additive inverse of 3. And you could say this for any number. 1 billion, the additive inverse of 1 billion is negative 1 billion because 1 billion plus negative 1 billion is just 0. So I've already gotten this question a lot from folks, and I love this question. Like, why do we care about this? Why do we have to do this? This is easy, blah, blah, blah. And the reason we are spending time really working on this is that the additive inverse is the foundation of algebra. And I've seen this time and again where students try to rush through this part of it, and then when we get into our algebra work, issues start to arise. So I really encourage you all to work on gaining this conceptual understanding of why this works. It will absolutely benefit you. So just a little bit of a conceptual understanding of that additive inverse. So some places we see it. The context. A hydrogen atom has 1 proton and 1 electron. There's our 1 proton and our 1 electron. So the atom is a neutral charge. It has a 0 charge. That's the net result in words. So how many 0 pairs does it have? Well, it has 1 0 pair. It had 1 positive and 1 negative. Another example, I took 4 steps forward and 3 steps back. So the net result is this. I am 1 step ahead of where I started because we have 1, 2, 3, 0 pairs, right? Every step forward and step back creates a 0 pair. So 3 0 pairs, the resulting of 1 positive step. So what I mean by modeling is that we need to be able to show why things work using some kind of image. I firmly believe that if you cannot model something, you don't truly understand it. So knowing the procedure of a thing, like knowing that, well, 2 plus 2 is just 4, without being able to show why, you don't understand it on this deeper level. So we're really going for these deep conceptual understandings with this modeling. Because we are not in person, I'm going to have you use the plus and the minus signs in your work, just so that you don't have to figure out how to draw things if you don't have those tools. But an example of how to model something is if I had this right here, this model represents 0 because 1 positive and 1 negative is a 0 pair, right? Additive inverse, that is 1 plus negative 1. So this is the same as saying 1 plus negative 1. So my argument would be additive inverse. Okay, right here, this model represents, well, I have 3 positives and 2 negatives. So I have a 0 pair here, and I have a 0 pair here. So this model represents 1, and my argument is 3 plus negative 2 equals 1 because of the additive inverse. So I'm going to ask you to do a little bit of modeling on your own. You're going to see something that looks like this. It's going to say for the expression below, make a sketch using plus and negative tiles. Since we're not in person, you don't have these tiles. It might be helpful for you to just like rip up some pieces of paper to use. Or I use coins sometimes, and you can use like pennies for positive, dimes for negatives, or something along those lines. But whatever helps you at home. You're going to locate the 0 pairs, and you're going to record the simplified value for each expression. So what that means here, so I have A is negative 8 plus 2. So I'm going to draw negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm adding a positive 2. So always start with that first term and then move to the second term. I like to put my second term below the first. Remember, a term is the value that is separated by your operation. So our first term is negative 8, our second term is 2. So I'm adding a positive 2. Next, I'm going to locate my 0 pairs. Well, there's a 0 pair, and there's a 0 pair. So what I'm left with is 6. Oh, there's my cat. So I'm left with a positive, a negative 6, I'm sorry. So my answer is negative 6. Here we have, oh, my cat really doesn't want me to do work right now. Okay, here we have negative 4. So I'm going to add my first term, 1, 2, 3, 4. Then we're adding a positive 8. So again, I'll put that second term below that. 1, 2, 3, 4, 5, 6, 7, 8. And then we're adding another negative 2. So I'm going to put that in a third row. 1, 2. And I like to do it as so I can really clearly identify my 0 pairs. So now I'm going to locate those 0 pairs. There's 1, 2, 3, 4, 5, 6. So all of those just created zeros, and what we are left with is a positive 2. So I can say that this equals 2. So negative 4 plus 8 plus a negative 2 is 2. All right. So now you're going to see a couple of exercises for yourself to do using addition with integers, and then we will have another little video. Thanks, y'all.